So we must find A, B, C, and D. So cosine theta, sine beta, cosine 2 theta, and cosine theta plus beta. And given the criteria we have, sine theta is equal to 1/3. So immediately, the first thing we should do is draw a unit circle, right? So now we have sine is equal to 1/3. So we just draw y is equal to 1/3. It's one of these 2 points, one of these two intersections. We do y is equal to 1/3 because sine is opposite. And the height is 1/3. So we draw y is equal to 1/3. And the criteria given is theta is greater than pi over 2 and less than pi. So we know that pi over 2 is this line right here and pi is this line. So it has to be in between here. So out of these 2 points, only this one is viable. So we get rid of that, draw the triangle for that point right there. Cosine beta is equal to negative 1/3. We know cosine automatically, we should know x. We should think x. So x is equal to negative 1/3. And looking at the criteria, it has to be beta is greater than pi. So this line, and less than 3 pi over 2. So we know that it has to be this point because it's in this quadrant and not this point. So immediately get rid of that and we can go with draw this triangle. So once we have this triangle drawn, we basically know, well, we have all the information that we need to find out the rest of these. So the first one we have is cosine theta. That's the first up. Cos theta. And what is cosine theta? Easiest way to find out is we know, take the theta triangle that we have, and we know that we have this here 1/3 and this here 1. So we do 1 squared minus 1 over 3 squared is equal to b squared. We calculate all that out. 1 minus 1 over 9 is 8 over 9. Take the square root of both of that and we end up with, we leave off with square root 8 over 9. Second triangle, which is beta. Oh, no. Sine beta. That's what we're looking for next. So we use a second triangle. So we're giving cosine, so 1/3, and the hypotenuse 1, same thing. 1 squared minus 1 over 3 squared is equal to this line squared. And our final answer is square root 8 over 9. So we have sine beta square root 8 over 9. To clarify how I got that, we know that cosine is 1 over 3 and the hypotenuse is 1. So using Pythagorean theorem, we can find out the last missing leg. And so these two answers are the same, which is due to a very good reason, in which they're basically the same triangle, just in a different position. The C, cosine 2 theta. Now, this is a more interesting one. What we can do is use the theta triangle and find the angle here, but in radians. So we do, well, the easiest way to do is second, on inverse sine 1 divided by 3. So 1/3. This is because we want to find here, and we have a good number, 1 over 3. So sine is opposite over hypotenuse. So we have 1/3 over 1 because the hypotenuse is always 1. So we can just write as 1/3. Sine, inverse sine 1/3, we get this as our angle measurement in radians. What we have to do now is multiply by 2 because the point of this is to find cosine 2 theta. So times 2 is that long decimal and put that into a cosine function, and we have 0.7777. It's infinite. In fraction form, we have 7 over 9. So cosine 2 theta is equal to 7 over 9. We have one more, cosine theta plus beta. This one's a little bit more complicated. So first of all, we need to find theta and we need to find beta. So the function for finding theta, like I said, inverse sine opposite over hypotenuse. So 1 divided by 3. 1 divided by 3. And then parentheses plus the function to find beta, which is the angle right here. So we know we have here, which is 1/3. Here's hypotenuse. So we can do inverse cosine 1/3. And we end up with this fancy decimal. Once we got that, we can input that into the cosine function. So cosine second and 0. So now we know cosine, cos, parentheses theta plus beta is equal to 0. So to find all 4 of these, this is how you do it. Easy peasy.